Okay, so this is the 2023 Higher Level Applied Maths paper question 2. A university has decided to improve the paths on its campus. In the network shown below, the nodes labelled with the letters X and Y represent the two entrances to the campus, and the nodes labelled with the letters A to N represent the key buildings on the campus. The edge represents the paths, with the weight of each edge representing the cost in euros of carrying out the improvement work for that path. The university decides that the first part of the work will be to provide an improved route between entrance X and entrance Y. Use Discra's algorithm to find the route between X and Y that is cheapest to improve. Calculate the cost of carrying out such improvements. Relevant supporting work must be shown. Okay, so let's start at node X. So I'm going to start here. This is going to be quite big, so I need a lot of room. So let's start with X and let's start here. So we need to divide this into three parts here. This is node X. It's the first node, and the distance from X to X is going to be 0. So this is our first completed node, if you like. So what we've got to do now is just look at where this node leads to. So it leads to A, B, and C. So I'm going to draw those in now. Let's put A here. So this is A. Let's put B here. And we put C down here. A, B, and C. So we need to join these up. So 1, 2, 3 paths to A, B, and C. So let's see, we've got 3,400 going to A. So I'll just put that in here, 3,400. We've got 2,500 going to B, 2,500. And we have 1,250 going to C, 1,250. So I'm going to put these in here. So this is going to be 3,400 here, and that's coming from X. We've got 2,500 here, and that's coming from X. And we've got 1,250 here, and that's coming from X. So what we need to do is look at the lowest one of these. So the lowest here is we've got 3,400, 2,500, 1,250. So it's going to be this one here, C. So this is going to be our next completed node. So this is going to be number 2, and I'm going to put the final value here, 1,250, and that comes from X. Okay, so now what we need to do is look at all the nodes that C leads to. So let's have a look at those. So C is going to lead to B and F. So I'm going to draw those in. We already have B, so let's just connect those up. So B is, from C to B is 900. So let me just put that in here, 900. And if you add the 1,250 plus the 900, that gives 2,150. That's lower than this value here, so I'm going to put it in. So that's 2,150, and that's come from C. Now, the other node that C goes to is F, so let me just draw that in. It's going to be down here somewhere, let's say. And this is F. And let's see, we have 3,900 here, so I just need to write that in, 3,900. Now if you add 3,900 to 1,250, that will give us, let's see, 5,150, and that comes from C. So I think that's it from C. We're just going to B and F. Okay, so now we need to look at all the uncompleted nodes. So we have this one here, A, which is 3,400. We have B, which is 2,150, so that's lower, so that's okay. And then we have down here at F, we have 5,150. So the lowest one is going to be this one here at B. So that's going to be our next completed node. So that's going to be number 3. It's going to be our third completed node here, and it's 2150 coming from C. So now we've got to look at all the nodes that are connected to B. So let's have a look at all of those. So B is connected to G and B is connected to F. So G and F. Okay, so we've got to connect B to, let's say, F first. So if we come down along here, and we can see that it is 2150. So it's 2150 here. So if you add 2150 and 2150 here, that'll give us 4300. 4300, and that's coming from B. Now B is also connected to G, so we need to draw G in as well. We don't have that yet, so let's put G in here. Okay, so this is G, and the weight of that path is from B to G 4200. So we're going to put 4200 in here, add that to 2150, and that gives us 6350. 6350, and that's coming from B. Okay, and I think that's it from B. B is just connected to G and F, nothing else. So okay, next thing we need to do is look at all our uncompleted nodes. So we've got 3400, we've got 6350, and we have 4300. So the lowest one then is this one up here, A here, so that's going to be our fourth one. So we're going to put 3400 up here, that comes from X, and this is going to be number 4. Okay, so let's see what A is connected to. So A is connected to D and E. A is connected to D and E. So we don't have either of those, so we need to draw those in. So let's do D up here. This is D, and let's say we put E here. And we need to connect these. So A is connected to D and E. So we've got 2650 here. 2650. And E is 800. 800 here. Okay, so let's add these then. So you've got 3400 plus 2650. So that's going to give us, let's see, for D, that's 6050. And that's coming from A. Along here we've got 3400 plus 800. That's 4200. And again, that's coming from A. Okay, and I think that's it from A. So what we've got to do now is look at all the uncompleted nodes again. So it's 6050, 4200, 6350, and 4300. So the lowest one here is actually at E. So E is going to be number 5. So this is our 5th completed node, and that's 4200, which has come from A. Okay, so let's see what E is connected to then. Well, E is connected to D, so we can connect E up to D here. And if E is connected to D, it's 1750. 1750. You add these two and you get 5950. 5950 is lower than this, so we can write it in, 5950. And that has come from E. Now E is also connected to, actually it's just connected to D, nothing else, so that's okay. So we're actually finished. So let's see, what have we got now? We have 5950, we have 6350, and we have 4300. So this one here is going to be the next one then. So the last one was number 5, so this one must be number 6 down here at F. This is 6, and it is 4300, 4300, which came from B. Okay, so let's see what F is connected to then. So F is connected to H and I. H and I. So we don't have those, so let me just draw those in. So that's H, and we have I down here. And those weights are, let's see, to H is 1600. That's 1600, and to I it is 2200. 2200. Okay, so let's add these then. So you add 4,300 to 1,600, and that gives 5,900, which is come from F. And we have 4,300 plus 2,200, so that's 6,500. 6,500, and that's also come from F. Okay, so that's done now. Let's have a look at all our uncompleted nodes again. So let's see, we have up here, we have 5,950, 6,350, 5,900. So this is the lowest so far, 5,900. We have 6,500. So H then is going to be our next one. Our last one was number 6, so this one here is going to be number 7. So let's put 7 in here, and it was 5,900, which came from F. So let's see what H is connected to. Okay, H is connected to G and I. So H is connected to G and I. Let's see what the weights are. So we have 1350. And we have 1800. 1350 and 1800. So let's add these. So if you add these two numbers here, you get 1350, 5900. So that gives 7250. That's bigger than this here, so I'm not going to put that value in here. Now if you add these two then, you get 7700. That's also bigger than this, so I'm not going to write that in here. Okay, so let's have a look at our uncompleted nodes again. So let's see, we have 5950 up here, we have 6350 here, and we have 6500 here. So the lowest one here is going to be D. So D, the last one we did was 7, so this one is going to be number 8 up here. This is 8, and this is 5950, and that came from E. So let's see what D is connected to then. So D is connected to J and G. So D is connected to G. I got to go around here, and it's also connected to J, which is a new one here, so I'll just draw that. Let's see, this is J, and that's connected there. The weights are, let's see, to J is 3,000, and to G then is 650 here. Okay, so let's add all of these then. So you got 5,950 plus 3,000, that is 8,950. And that came from D. And then if you add these two here, you get 6,600, which is bigger than this, so I'm not going to write that in here, and that's it. Okay, so let's go again then. Let's see, we have 8,950 here, we have 6,350 here, and we have 6,500 here, so it's going to be, G is going to be next then. That's going to be number 9. We had 8 up here, so this is going to be number 9. This is 9 here, and 6,350, and that came from B. So let's see what G is connected to now. So G is just, G is connected to K and H. So K and H. So G is connected to H already. We have that here. So we just need to do a new one here. So G is connected to K. So this is K here. And the weight there was 2,500. 2,500. Okay, and I think that was it. Is it? G is connected to K and H. D we already have. H we already have. So K is the only new one really. Okay, so let's just add those two then. So we've got these two here to add. We've got to add 6350 to 2,500. That's 8850, and that came from G. We have 8950, 8850. We have 6500. Okay, so we're on number 9 up here. So this must be number 10 then for I. So I is number 10. And it's 6500, which came from F. Okay, let's see what I is connected to then. So I then is connected to H, which should already be there. Yeah, that's this one here. It's connected backwards. We have that one. So we have it connected to K, 2350. So I is connected to K. So we need to connect I up here to K. The weight is 2350. 2350. And it's also connected to L. So L is a new one, so we need to draw that. So this is L, and the weight is 4750. Okay, so that was I. So we have that connected to everything it should be connected to at this stage, I think. So we have that one, we have that one, we have K, and we have L. So let's just add these up then. That's already done, that's already done. So this one here, so we need to add 6500 to 2350. So that should give us 8850. So that's the same here, so we don't have to worry about that. Now we need to add these two, 6500 plus 4750. That's 11250. And that came from I. Okay, so we're getting there anyway. Let's see, where are we now? We're at 8950, 8850 here, and 11250. Okay, so we were at 10 here, so the next one is 11. So K then must be 11. So that's our next completed node. So that's 11, and it's 8850, which came from G. Okay, so let's see what K is connected to. So K is connected back here, which we should have, and it's connected to J, which we don't have, so I need to connect these two up. And the weight there is 1900. Okay, it's also connected to L. So K is connected to L, which is down here. And the weight there is 950. So the weight from K to L is 950. And it is also connected to M. So we need to draw in M. So I put M here. And the weight there from K to M is 2400. Okay, so let's add all these up. We have 8850 plus 1900. That's 10750, which is bigger than this, so I won't write that in. If we come up along this way, then we've 8850 plus 2400. That's 11250. So we put that in here. And that came from K. And if we come down here then, we have, let's see, 8850 plus 950. That's 9800. That's lower than this, so I'm going to include that here. So it's 9800, and that came from K. And that's it, I think. Yeah, that's everything. So let's see, we need to look at our uncompleted nodes again. So let's see, we have 8,950, we have 11,250, and we have 9,800. So it's going to be this one here. J then is going to be number 12. So J here is number 12, and its value is 8950, which came from D. So let's see what J is connected to. Okay, so J is connected to M, 950. J is connected to M, which is 950. J is connected to K, 1900. We have that already. And that's really it. It's connected back here as well, but we finished that. So it's really just this one here. So let's see. Let's add those. 8,950 plus 950. That's 9,900. That's lower than this value here, so we're going to use that. So it's 9,900, which came from J. Okay, let's see what we've got now. We have 9,900. We have down here 9,800. I think that's it. So we're going to use this one down here. L then is going to be number 13, 9,800. So this is 13, 9,800, which came from K. So let's see what L is connected to. L is connected to K, which we have already. L is connected to Y, which we don't have, and N, which we don't have. So we need to put those two in. So let me just draw those two in here. So we need N and Y. And I think that's it, just those two. Okay, so we got 2,300 here. And we have 1950 along here. So let's add these two. So if you add 9,800 to 2,300, that gives 12,100. 12,100. And that came from L. And along here then to N, we are adding 9,800, 1,950. That's 11,750, I think. 11,750, yeah. And it is from L as well. Okay, so we're just about there. Let's see what we've got left then. We've got 9,900, we've got 12,100, and we've got 11,750. We're at 13, so that means the lowest one is this one, so M must be number 14. So M is 14, and we got 9,900, which is from J. Okay, let's see what M is connected to. M is connected to Y anyway. So we're coming down here. The weight there is 1550. And M is connected to K, which we already have, and back here as well, just those three paths there. So that's okay. So let's just add these up. 9,900 to 1,550. That's 11,450. 11,450 is less than this, so I'm going to include that. 11,450, which came from M, and that is it. So let's have a look at what we're left with. So we're left with 11,450 and 11,750. So that means our sync mode here is actually the lowest. So that's going to be our number 15. So it's going to be 15 here and 11,450 from M here. Really, that's as far as we need to go, but there is another path here, which is not going to make any difference. I think it's 1,800. So 1,800, and if you were to add these two here, you're going to get more than this. So this is our final answer here, if you like. Okay, so that was it. It's kind of a long-winded question and not enough space on the paper. I thought you probably had to turn it sideways, but that's my answer there anyway for this part of the question. Calculate the cost of carrying out such improvements. So the cost then, the answer then, is 11,450. That's this number here, 11,450 euros. Now, did we have to do anything else? Let me see. Use this now to find the route between X and Y that is the cheapest to improve. So we've got to write down the route as well, calculate the cost as well. Okay, so let's do that. So we have the cost. The route then the root is going to be. So we can just look at our sync node, and our sync node tells us that we ended up here at y anyway, but this one here came from m, so it's going to be ym, or it's going to be, we can start out here at the end, y, then back to m. So you go up to m there, you can see that we came from j, so the next one is going to be j here. And if we go back further then, if we're at j, we remember we came from d, so it's going to be here, so it's going to be d, and from d we came from e, so e is next here. If we go down to e, you can see here that we came from a here, so we go to a, and then finally x. So it's xae, djmy. So they're my two answers there. It cost 11,450, or would cost that amount if you go by root xae, In part B, we are talking about two smooth spheres, P and Q, have equal radius and are of mass m and 2m respectively. P and Q collide obliquely, and they give us a diagram here. The line joining their centers at the point of impact lies along the I-axis. So this is our I-axis along here, and J will be up along this way. Before the collision, sphere P moves with a velocity of 4 meters per second at an angle alpha with the I-axis. So it's moving up along this way, and this is our angle alpha here. The sine of alpha then, so they're giving us the angle here. It's sine inverse 4 over 5. Before the collision, sphere Q moves with a velocity of 3.2 meters per second perpendicular to the I-axis, so it's moving up along this way. The coefficient of restitution between the spheres is e, where e is between 0 and 1. Calculate in terms of e the velocity of each sphere immediately after they collide. Okay, so the way we're going to approach this initially is just to write down the details here. We've got the velocity before, we've got the mass, and we've got the velocity after impact. So let's write all this down then. Looking at our diagram here, we have P moving in this direction at an angle alpha to the I-axis. So if you think about that, if this is the I-axis here, and P is moving in that direction, if this is alpha here, you know, this is going to be alpha here as well. So we know that this is 4 meters per second up along this way. So if we look at our resolved vectors, if you like, along this way and up along this way, this here is going to be 4 cos alpha. This up along here is going to be 4 sine alpha. And we probably just should break this line here a little bit. So just some dotted lines along there. Okay, so we have our resolved vectors, 4 cos alpha, 4 sine alpha. So our velocity before is going to be 4 cos alpha I plus 4 sine alpha j. Remember, this is sphere P. Its mass then is P and Q, mass m and 2m respectively, so this is going to be mass m. Now the velocity afterwards, remember, because the spheres are impacting obliquely, the j velocity is not going to be affected, but the I velocity will be. So our I velocity afterwards we don't know, so let's just call it P plus. Now the j velocity is not going to be changed, so it's going to be plus 4 sine alpha j. Now the Q sphere, on the other hand, will have velocity, it's just going in the vertical direction upwards, so its velocity beforehand is going to be 0 in the I direction and 3.2 in the j direction. Its mass is 2m. Again, we don't know what the velocity is going to be afterwards, so we just call it q in the I direction. and then in the j direction, then it's going to be the same as the velocity beforehand, which is 3.2 j. Let's just work out our sines and coses here. We know that the angle alpha is sine inverse 4/5. So if you imagine you've got a triangle, let's say this is our alpha. We know that the sine of alpha, we're told that in the question, the sine of alpha is 4/5. So that means this has to be 4, this will be 5. And you can see this 3, 4, 5, 3, 4, 5 right angle triangle. But just to work it out here, you can call this maybe x here. X squared plus 4 squared is equal to 5 squared. So you've got x squared plus 16 is equal to 25. X squared is equal to 9. X is equal to 3. So we now know therefore that the sine of alpha, the cos of alpha, and the tan of alpha if we need them. So the sine of alpha is 4/5, we know that. Cos of alpha now is going to be 3/5, and the tan, if we need it, is 4/3. So we can just substitute the sine and the cos in up here anyway, so let's do that. So 4 cos alpha here, so that's going to be 4 times 3/5, so that's 12/5 I, plus 4 sine alpha. Well, sine alpha is 4/5, so that's going to be 16/5j. So that's our velocity of our p-sphere before impact. Afterwards then, it's going to be still pi plus 4 sine alpha. Well, sine alpha is 4/5, so that's going to be 16/5j. So our q-sphere, we don't have to worry about anything there, but now we have our velocities before and afterwards for both our spheres. Okay, so let's start into the equations then that we have to work out. So the first thing we're going to do is look at Newton's law of restitution here. So it's going to be minus E is equal to V1 minus V2 over U1 minus U2. So in our case then, that's going to be, afterwards it's just going to be P minus Q, the velocity afterwards. So it's just going to be these two here, P minus Q. And then beforehand it's going to be this minus this, 12/5 minus 0. Now since I have a decimal here, maybe I'll just change this to a decimal as well. So that's going to be 2.4. So we have 2.4 minus 0 here. 2.4 minus 0. And that's equal to minus E. So if we just multiply that across then, let's see, we get minus 2.4 E is equal to P minus Q. We'll just call that equation 1, and we'll have a look at our conservation of momentum equation now. So this is our principle of conservation of momentum. So let's work through that. Now, we know that our formula is going to be m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So the momentum before is going to be equal to the momentum afterwards. So let's put in our numbers here. Now we have m1 times u1, so that's going to be 2.4 times m, plus our second mass is 2m, and that's going to be multiplied by 0. And then the momentum afterwards, again, is going to be m times p plus 2m times q. Okay, so let's just simplify this so we can cancel all the m's anyway. So we've got 2.4 is equal to p plus 2q. This is our equation number 2. Okay, so let's put these two equations together. So what I'm going to do is I'm going to multiply this equation by 2. So that'll give me, let's see, we'll have minus 4.8 E is equal to 2p minus 2q. This is equation 1 multiplied by 2. Let's add these. So you've got 2.4 minus 4.8e is equal to 3p. And these will cancel. And then if you just divide by 3, that'll give you a p-value of, let's see, 0.8 minus 1.6e. Okay, so let's work out what q is then. So let's just take one of the equations. That's our p anyway. So let's work out what q is. So I'm going to use this one. Let's see, p minus q is equal to minus 2.4e. This is equation number 1. Let's stick p in there. So you've got 0.8 minus 1.6e minus q is equal to minus 2.4e. So let's just sort all this out. So let's just get the q on its own. So you've got minus 2.4e plus 1.6e minus 0.8. That gives us minus q is equal to minus 0.8e minus 0.8. So that means q then, q is going to be 0.8e plus 0.8. And that's it. Okay, so all we've got to do now is just write in the values for p and q here. So let's see, we've got pi plus 16 over 5j. Remember we had pi plus 16 over 5j. This was our p sphere, and our q sphere then was qi plus 3.2j. It was qi plus 3.2j. So let's just stick in our p's and q's here and change this to a decimal as well. So the p is 0.8 minus 1.6e I plus 3.2j. So this is our p sphere. And our q sphere then is, the q is 0.8e plus 0.8, and this is I plus 3.2j. So that's it. This is our m mass here, if you like, and this is our 2m mass here. Okay, and that's it for this question.